All right, so everyone go ahead and do the factoring and the math knowledge question for today. Pause the video, and then once everyone is finished, you can unpause the video and I'll go over the correct answers. So for the factoring, we're going to do remove, replace, reduce. If you've had me before, then we've gone over this method. I'm going to go over it again today. If you haven't had me before, then you probably don't call it remove, replace, reduce, but some may call it the Berry method, I think it's called. And some of y'all may do it by factoring by grouping. Doesn't matter to me how you do it, as long as you know how to factor it. So if you don't like my method after you see it, you don't have to do it. That won't hurt my feelings. I just may not understand the method that you choose to do. So if you have a question about it, I may or may not be able to help very much, depending on which method you're picking. All right, so you're going to remove the 3 by multiplying it by the 26. So it's going to become x squared minus 7x minus 78. And then we're going to factor this. And so it's going to be x minus 13 and x plus 6. Then you're going to replace the 3 that you removed in the beginning. And then this 3 and 13 do not divide by anything, so they don't reduce. So we leave it as 3x minus 13. The 3 and the 6 both divide by 3, so we're going to be left with x plus 2. And so that would be your answer for the factoring. For the math knowledge question, we typically consume 67.5 pounds of sugar every year, and they want to lower it by at least 20%. So we want to know how much sugar they're going to consume next year. So if they're going to lower it by 20%, they're still going to be consuming 80% of this sugar. And so 67.5 times 80% would give you 54. And so that's how many pounds of sugar they are going to consume next year, which is a ton of sugar. Okay, so we're looking at lesson 19 today, the derivative, and then slopes of curves on a graphing calculator. This is a calculus concept. You haven't probably dealt with this before, but hopefully whenever we finish, you will understand the derivative and understand slopes of curves on a graphing calculator. So slope of a line tells us how steeply it rises or falls. So this slope may be about 1. This slope is going to be closer to 0. This slope is going to be a really big number, maybe 7, 8, 12, but it tells you how steeply it rises, or if it was going down, how steeply it falls. You've dealt with slope before. So we want to just look at positive versus negative. If you look at the point S, this line that's going through it, it's tangent. At point S, it's a negative slope. P, if you look at P, it is a slope of 0. And then if you look at the one that's tangent to Q, it is positive. And then if you look at the one that is positive, that is tangent to R, it's positive, but it's greater than the slope that went through Q. It didn't give us numbers for us to be able to figure out what the slope is, just what kind, positive or negative. For nonlinear equations, the slope of your curve is determined by the slope of the tangent line to the curve at that point. And we talked about that a couple of lessons back. If you want to find the slope of a curve at a particular point, you have to look at the tangent line at that point. And the derivative is going to tell us the slope of your graph. You need to learn that derivative and slope are synonymous with each other in calculus. So derivative and slope, same thing. This is our derivative formula. You can write the derivative as f prime. That little thing right there is a prime. So f prime. And then it's the limit as delta x. This is a Greek symbol. That means delta. X approaches 0. And then it's this formula, f of x plus delta x minus f of x all over delta x. So that is how you find the derivative. You evaluate the limit. These also mean derivative. So we have f prime of x. We also have d over dx, d sub x, and dy over dx. All of those mean derivative. So we'll talk about this more later, but there were actually two people that invented calculus. Yes, calculus was invented. It was invented almost at the exact same time, and one of them might have discovered it, invented it first, but the other one published it first. And so in the math world, that's a big controversy. Most people really, though, give credit to both of them for inventing calculus. But some people say that one of them invented it over the other. And if you ever take higher level math classes in college, you may hear a little bit more about that. We'll go into it a little bit more in another lesson. But the reason we have all of these different types of ways to write derivative is because there were two people that created it, and so they both had their own notations. So one of them did dy's and one of them did primes, and they're both good. Some of them are better for certain types of problems than others, so we'll use both notations throughout the book. All right, so we have y equals x squared. We want to find dy over dx. And so on these, you need to make sure to show your work. And so I'm going to go through this. And the first thing that you need to do is to write your formula for your derivative. So dy over dx, that's the same thing as f prime of x, equals the limit as delta x approaches 0 of x plus delta x minus f of x all over delta x. And so now that we have our formula written out, we can plug in what our function is. So the limit as delta x approaches 0, and our function is x squared. So x squared, our x is going to become x plus delta x. So instead of it just being x, it's now x plus delta x squared. And then minus x squared, because that's our function, all over delta x. And so now we need to try and simplify this. So we're going to start off by factoring the numerator. Not factoring, distributing. So if you distribute, you're going to have x squared, and then you'll have 2x times delta x. And I always put parentheses around the delta x because it's a different variable from x. And then plus delta x squared. Minus x squared all over delta x. From here, this x squared and this x squared are going to cancel. And so I'm going to have the limit as x, delta x approaches 0. And then I'm going to have 2x delta x plus delta x squared all over delta x. After that, all of these three terms have a delta x in common, so we can cancel one of them, and we're left with the limit as delta x approaches 0 of 2x plus delta x. And then we can plug in delta x equals 0, and so that leaves us with just 2x. And so that would be your derivative. Okay, so that's how that works. So this is the slope. This is the derivative, and it is the slope. So you want to keep that in mind for the next question. It gives us a function. Again, it is x squared, and it wants us to find the slope at the tangent line, the slope of the tangent line at x equals 4. So our derivative is f prime of x. Our derivative was 2x, and this is your slope. And it wants to know when x is 4, what is our slope? Well, all you're going to do is plug in a 4 here, and so that's going to give you an 8. And so 8 is your slope. So you don't have to rework to find the derivative. We just found it, so use that information. and then just plug in 4. Looking at the next example, we have 4x. We want to find, so it says d sub x of y. So all that's asking for is the derivative. So we're going to start off with our formula. So our derivative is the limit as delta x approaches 0, f of x plus delta x minus f of x all over delta x. So that's your formula, and hopefully you'll memorize it pretty quickly just because you're having to write it for several problems in a row. So now we plug in our 4x. So instead of it being 4x, it's going to be 4 times x plus delta x. And then f of x is just 4x all over delta x. So we can distribute, and we'll have 4x plus 4 delta x minus 4x all over delta x. And so the 4x's cancel. And so we have 4 delta x over delta x. And so our delta x's cancel, and we're just left with 4, and we don't have to worry about trying to plug anything in because there's no delta x left. So our answer is just 4. Okay, so now we're going to look at another one. Use the definition of the derivative to show that the derivative of a constant function is 0. So c is just some number here. So the first thing we're going to do is write our formula. So the derivative is the limit as delta x approaches 0 of f of x plus delta x minus f of x all over delta x. So when we plug in our function, this is the part that people usually get confused on. Our function is c. There is no x here. So if we have a 4 and we plugged in x plus delta x where there's an x, there's no x for us to plug it into. So it would still just be a 4. So the c stays as just a c. There's nowhere to plug x plus delta x in because there's no x over here. So we're just left with c. And then our f of x is just c. So we have c minus c over delta x. Well, from here, you end up with 0 over delta x. Well, 0 over delta x is just 0. So the limit as delta x goes to 0 of 0, you can't plug delta x in because there isn't one. We're just left with 0. And so that's how you would show that the derivative of some constant number is just 0. So the derivative of 4 is 0, the derivative of 10 is 0, the derivative of 1,000,000 is 0. And again, derivative is slope. So if I graph the line y equals 4, that is a horizontal line. And what is the slope of a horizontal line? The slope of this line is 0. And so the derivative should equal 0, and it does. So that's how you can think of it as well. Okay, we're going to look at another example. We have y equals 1 over x, and we want to find dy over dx, which is your derivative. So dy over dx equals our formula, the limit as delta x approaches 0 of f of x plus delta x minus f of x all over delta x. So when we plug in our function, 1 over x is going to become 1 over x plus delta x. This all gets replaced by, this all replaces your x. And then minus, our function is just 1 over x all over delta x. So now you have to use some properties that you learned in Algebra 2, and you probably were asking, why do I need to know how to do this? And it's to simplify these calculus problems. And you're probably saying, why do I need to know these calculus problems? We're getting there. We're going to use them in some more real life applications, but we have to know the basics. We have to know the building blocks. So you're learning this to be able to apply it later. So we can't have a complex fraction, so we need to make it a simple fraction with only one fraction bar. So the first thing that we need to do is to make a common denominator in our numerator. So that common denominator is going to be x times x plus delta x. And so this is missing the x, so 1 times x, and then minus, this one is missing the x plus delta x, so x plus delta x. So then we can simplify it by saying x minus delta x over x times x plus delta x times the reciprocal of the denominator. And this x minus x will cancel out. So I end up with the limit as delta x approaches 0, negative delta x over x times x plus delta x times 1 over delta x. And this delta x cancels with that delta x. So I have the limit as delta x approaches 0 of negative 1 over x times x plus delta x. From there, I can plug in a 0 for my delta x. So this is going to become a 0. And so I'm left with negative 1 over, if this is 0, I just have x times x, which is x squared. And so that would be your derivative of 1 over x. Okay, so that's the answer for that one. For the next example, 19.6, we're going to find the slope of the tangent line that can be drawn to the graph of 1 over x at x equals 2. So when it asks about slope, we need to use the derivative. And we just found the derivative of 1 over x. The derivative of 1 over x we found was negative 1 over x. It wants to know when x is 2. So all we need to do is plug in a 2 into this equation. So if you simplify that, you have negative 1 over 4. And so that would be the slope for that problem. All right, we're going to look at using the calculator. So if you have an older calculator, you may need to do this. If you have an 84 version or newer, then you don't have to worry about that. Most people don't have older calculators, so I'm not really going to go over that much, other than to say that these are the steps you would do. Go to Math, 8, enter, and then you're going to type in this, and then enter, and it'll work. But for everybody else, we're going to do it this way. So you can go to your graphing calculator. You're going to go to Math. Over here, right under the green button, you should see Math. And we're going to use derivative, which is number 8 in derivative. And it comes up like this. It should come up like this. If you have an older calculator, it's not. And you'll have to use that information here that I typed up. So our variable that we're dealing with is x, so we're going to put x. Our function is 1 over x. And then when x equals 4. Because that's what it says over here. Our x value is 4. And I get negative 0.0625000039. And so that is close to what it should be. If you do it algebraically, you'll actually get a fraction. And so I'm going to use our formula that we just used a minute ago. The derivative of x was negative 1 over x squared. And so if we plug in a 4, we get negative 1 over 4 squared, which is negative 1 over 16. And if you go back to your calculator and you plug in negative 1 over 16, you get negative 0.0625. close to this. Sometimes the calculator isn't exactly accurate, so if it says approximate, then you can use it, and approximate it to 4 decimals would be 0.0625. But if it says to just find it and it doesn't say approximate, or it doesn't say to use a graphing calculator, and you gave me this whole answer, it would be wrong, because you're supposed to use your algebra or your calculus that you know to find the answer. So sometimes the calculator gives you wrong answers. So you just got, not wrong answers, but they're not precise. They're not exact. So just be careful whenever you go to use the calculator if it doesn't tell you to. Okay, so we're going to use another one to approximate the slope at the point pi 0. So we need to be in radians because this is a pi. So go change your calculator to radians. And if we're doing derivatives, we're going to go to math and then 8 for derivative. Our variable is x and our function is sine of x. And we want to know when x is equal to pi. And then you hit enter, and it gives you negative 0.999999833. And so what is that really close to? It is basically -1. We don't know how to find the derivative of sine just yet, but if you did it algebraically instead of using the calculator, you would get the derivative at pi equaled -1. So you would want to put -1 for your answer here. Don't put negative 0.9999. And even if you did, if you rounded it, it would actually be -1. Okay, so hopefully that helps you a little bit with derivatives and using the calculator with derivatives. You do get to omit number 21 on your homework tonight, so make sure to do that so we can go over any questions you have.